2:47 in the afternoon. April 12, 1934. Melbourne, Australia, Commonwealth Conference Hall. 287 delegates from 14 nations sat in folding chairs listening to presentations on agricultural irrigation efficiency. Session 4, Speaker 11. His name was Samuel James Rothwell. He was 41 years old. He was a civil engineer from the Murray River Irrigation District in New South Wales. He had traveled 374 miles to present a paper on gravity flow measurement using paired sluice gates. When he described his coefficient calculation method, 17 delegates laughed out loud. The conference chairman, Sir William Hudson, asked if Rothwell was joking. Rothwell said he was not. Hudson moved to the next speaker. The entire exchange lasted 4 minutes. Rothwell's paper was not included in the conference proceedings. The calculation method he presented that day is now codified in the irrigation standards of 14 countries and is taught in every major agricultural engineering program in the world. The device that proved it worked weighed 11 pounds and was made of cast iron and brass. Before you can understand why Samuel Rothwell was laughed out of that conference room, you need to understand what irrigation engineers were measuring in 1934 and why every single method they were using was wrong in exactly the same way. In 1934, gravity-fed irrigation was the primary method of watering large-scale agricultural land across Australia, parts of North America, India, Egypt, and southern Europe. Water flowed from elevated sources through channels and ditches to fields. The engineering challenge was calculating how much water was actually reaching the crops. Farmers paid for water by volume. Governments needed to know consumption rates to manage reservoir levels. Engineers needed flow data to design new systems. Every calculation depended on knowing the volumetric flow rate through the channels. Get that number wrong and you either flooded fields or starved them. You either overcharged farmers or bankrupted the water authority. The standard method in 1934 was the Manning equation. It had been published in 1889 by Irish engineer Robert Manning. It calculated flow based on channel slope, cross-sectional area, and a roughness coefficient for the channel material. The formula was Q equals 1 over N times A times R to the 2/3 power times S to the 1/2 power. Q was flow rate, N was the roughness coefficient, O was cross-sectional area, R was hydraulic radius, S was slope. Every irrigation engineer in the world used it. The formula was printed in every civil engineering handbook published between 1890 and 1940. The Manning equation had one problem. It was consistently wrong by 18 to 34% in field conditions. Not wrong because the math was bad, wrong because the assumptions it required could not exist in actual irrigation ditches. Manning's equation assumed uniform flow. It assumed the channel had a consistent cross-section for the entire length being measured. It assumed the slope was constant. It assumed the roughness coefficient was uniform across the wetted surface. It assumed steady-state conditions with no fluctuation in upstream supply. None of those assumptions held in working irrigation systems. Ditches were hand-dug or carved by early machinery. Their cross-sections varied every 20 feet. Slopes shifted wherever the land shifted. Channels accumulated silt in some sections and scoured clean in others. The roughness coefficient changed daily. Upstream flow fluctuated based on demand from other channels. Every single input Manning's equation required was a fiction in the field. Engineers knew this. They published papers about it. In 1926, C. Ramsar at the United States Department of Agriculture published a bulletin titled Flow of Water in Irrigation Channels. He documented measurement errors ranging from 21 to 39% when Manning's equation was applied to working ditches in California and Arizona. In 1929, A.N. Strahler published field data from Egypt showing errors between 15 and 41%. In 1931, the Indian Irrigation Commission published a report documenting similar failures across the Punjab canal systems. Everyone knew the equation did not work. They kept using it because no one had an alternative. The consequences were not abstract. In 1927, the Murrumbidgee Irrigation Area in New South Wales charged farmers for 43,800 acre-feet of water based on Manning calculations. The actual delivered volume, measured at the field level by farmers using their own methods, was later estimated at 31,200 acre-feet. The farmers paid for 12,600 acre-feet they never received. That is 4.1 billion gallons. At the rate charged, the overbilling totaled 8,240 pounds. Adjusted for the number of farmers affected, the average family was overbilled 47 pounds. For context, the average annual income for a farm family in the Murrumbidgee district in 1927 was 280 pounds. The overbilling represented 16.7% of annual income. Families lost farms over it. In 1930, the West Punjab Canal District in India experienced the opposite problem. Engineers underestimated flow using Manning's equation and allocated water to more fields than the system could supply. During the dry season of 1930, 1,847 farms in the district received less than 60% of contracted water. Crop yields fell. 412 families defaulted on land revenue. The district administration filed 87 foreclosures. The error was systematic. The flow calculation was wrong at the source. Samuel Rothwell did not start as an irrigation engineer. He started as a surveyor. He was born in 1893 in Deniliquin, New South Wales. His father, Thomas Rothwell, owned a 640-acre farm growing wheat and grazing sheep. The farm depended on water from the Denibuda irrigation scheme, which drew from the Edwards River. In 1911, Thomas Rothwell was billed for 186 acre-feet of water. He had measured his own usage at the field gate using a simple weir box. His measurement said 141 acre-feet. He disputed the bill. The Water Authority refused to adjust. Thomas paid under protest. In 1912, the same thing happened. Billed for 193 acre-feet, measured 138. Thomas died in 1914. The farm passed to his widow Margaret. She could not manage the land and the water disputes simultaneously. She sold the farm in 1916 for £1,840. The family had owned it since 1878. Samuel Rothwell was 23 years old when his mother lost the farm. He had been working as a survey assistant for the New South Wales Department of Public Works since 1912. In 1916, he requested transfer to the Irrigation Division. His supervisor noted in the personnel file that Rothwell had a personal interest in flow measurement accuracy. He was assigned to the Murray River District in 1917. Between 1917 and 1933, Samuel Rothwell measured water flow in irrigation channels across the Murray and Murrumbidgee systems. He used Manning's equation because that was the standard. He also used direct volumetric measurement at field gates when farmers requested verification. In every case where he could compare the Manning calculation to direct measurement, the Manning number was higher, not always by the same percentage but always higher. Over 16 years he documented 247 comparisons. The average error was 23.6%. Manning's equation consistently overstated flow. In 1931, Rothwell began asking a different question. Manning's equation failed because the assumptions were wrong. What if you measured the thing that violated the assumptions? What if you stopped trying to calculate flow from channel geometry and measured the energy loss directly? Water flowing through a channel loses energy to friction. That energy loss shows up as a drop in water surface elevation. If you measure the elevation at 2 points and know the distance between them, you can calculate the energy loss. If you know the energy loss, you can calculate the flow rate without knowing anything about the channel cross-section, the roughness, or the slope. You only need two numbers, the elevation difference between 2 points and the distance between those points. This is not new physics, it is basic hydraulics. Bernoulli published the principle in 1738. What Rothwell realized was that no one had applied it to irrigation channels because everyone assumed you could not measure elevation differences accurately enough in the field. The elevation drop in a working irrigation ditch over a short distance is small. In a channel moving 2 cubic feet per second over a 100-foot length, the elevation drop might be 0.4 inches. Existing surveying methods in 1931 could measure elevation to about 1-inch accuracy under field conditions. That was not precise enough. Rothwell designed a device he called a paired sluice gauge. It was a set of 2 vertical staff gauges mounted in the channel bed exactly 100 feet apart. Each gauge was a brass rod marked in increments of 1/16 of an inch. The rods were mounted in cast iron bases that were anchored into the channel bottom using expanding bolts. The bases weighed 11 pounds each. The brass rods were 30 inches tall and weighed 14 ounces each. The entire paired set cost £4 and 6 shillings to manufacture. The innovation was not the gauge itself. Staff gauges had existed for a century. The innovation was using 2 gauges at a fixed distance and calculating flow from the difference in readings. Rothwell called it the differential energy method. You read the water surface elevation at the upstream gauge. You read it at the downstream gauge. You subtracted. The difference was the head loss. You plugged the head loss and the distance into a formula Rothwell derived from the Darcy-Weisbach equation. The formula gave you flow rate. You did not need to know the channel cross-section. You did not need to measure slope. You did not need to guess the roughness coefficient. You measured the consequence of all those factors combined, which was the energy loss, and you calculated backward to get flow. Rothwell installed his first paired gauge set in March 1932 on a supply channel serving the Barraquin Irrigation District. The channel supplied water to 47 farms. The Water Authority had been billing based on Manning calculations. Rothwell installed the gauges and measured flow for 6 months. He compared his measurements to the Manning calculations. The Manning method said the channel was delivering an average of 4.7 cubic feet per second. Rothwell's differential method said 3.4 cubic feet per second. The farmers had been overbilled by 38%. The Water Authority did not believe him. They sent another engineer, Donald Frame, to verify. Frame used a current meter which directly measures velocity at multiple points in the cross-section. You measure velocity, measure the cross-sectional area, multiply, and get flow. Current meter measurement is accurate but slow. It took Frame 4 hours to complete one measurement. Rothwell's paired gauge took 2 minutes. Frame's measurement, 3.5 cubic feet per second. Rothwell's method was accurate to within 3%. Between 1932 and 1934, Rothwell installed paired sluice gauges on 19 channels across the Murray District. He published his results in the Internal Engineering Bulletin of the New South Wales Department of Public Works in December 1933. The report was 11 pages. It included methodology, installation instructions, cost comparisons, and accuracy data from all 19 installations. The report concluded that the differential energy method was faster, cheaper, and more accurate than Manning calculations or current meter measurement. The cost per installation was £4 6 shillings. The time to take a reading was under 3 minutes. The accuracy compared to current meter measurement averaged 4.2% error. The report was read by engineers in the New South Wales Department. It was not read outside New South Wales. In January 1934, the Commonwealth Agricultural Engineering Conference announced it would be held in Melbourne in April. The conference was organized by the Council for Scientific and Industrial Research, the predecessor to CSIRO. The purpose was to share research on agricultural water management across British Commonwealth nations. Delegates were invited from Australia, New Zealand, India, South Africa, Southern Rhodesia, Kenya, Canada, and the United Kingdom. The conference organizers invited submissions on irrigation efficiency, soil moisture measurement, and drainage engineering. Samuel Rothwell submitted his paper on the paired sluice gauge method in February 1934. The submission was accepted. He was assigned to Session 4, Agricultural Water Measurement, on the second day of the conference. He prepared a 20-minute presentation. He brought installation drawings, cost data, and accuracy comparisons. He did not bring a physical gauge. He later told a colleague he assumed the method would be evaluated on the data, not the device. The conference began on April 11, 1934. Session 4 started at 1:00 p.m. on April 12. There were 14 presentations scheduled. Rothwell was number 11. The session chair was Sir William Hudson, who was the chief engineer of the New South Wales Department of Public Works and would later become the chief engineer of the Snowy Mountain Scheme. Hudson was 52 years old. He had degrees from University of Sydney and had studied under Osborne Reynolds at Manchester. He was the most senior irrigation engineer in Australia. The first 10 presentations in Session 4 covered Manning equation refinements, current meter calibration, flume design, and sediment transport. Presenters came from universities and government departments in India, South Africa, and Australia. Every presentation assumed Manning's equation was the foundation. The discussions were about improving input accuracy, not replacing the method. Samuel Rothwell stood up at 2:43 p.m. He was introduced by Hudson as an engineer from the Murray District presenting on flow measurement. Rothwell began by describing the paired sluice gauge installation. He explained the differential energy principle. He presented his accuracy data. Then he said that Manning's equation should be abandoned for irrigation billing purposes because it was systematically inaccurate and his method was faster and cheaper. The room went silent for approximately 5 seconds. Then someone in the third row laughed. Then others joined. Rothwell stopped talking. Hudson asked if Rothwell was seriously suggesting that 45 years of irrigation engineering based on Manning's work should be discarded in favor of 2 sticks in the mud measured with a tape. Rothwell said yes, if the 2 sticks gave the right answer and Manning did not. Hudson asked if Rothwell understood that his method ignored channel geometry entirely. Rothwell said that was the point. Channel geometry could not be measured accurately enough to matter, so stop measuring it, measure the result instead. A delegate from the Indian Irrigation Service, whose name was recorded in the minutes as Mr. S.L. Malhotra, asked how Rothwell proposed to calculate flow in channels where sluice gates or other structures created backwater effects that invalidated the assumption of uniform energy gradient. Rothwell said you install the gauges far enough away from structures that the flow stabilizes. Malhotra said that could be hundreds of feet. Rothwell said yes, and it still takes less time than a current meter survey. Malhotra shook his head. Another delegate, Dr. Peter Caulfield from the South African Department of Water Affairs, asked whether Rothwell had tested his method in channels with high sediment load where bed elevation changes daily. Rothwell said he had not. Caulfield said the method was useless in half the irrigation systems in the world then. Rothwell said the gauge bases could be re-leveled if bed elevation changed, and you would know it changed because the downstream gauge would read higher than expected. Caulfield said that was impractical. Hudson thanked Rothwell and called the next speaker. Rothwell sat down. His presentation had lasted 6 minutes. The conference minutes, which were published in August 1934 by the Council for Scientific and Industrial Research, include a one-sentence summary of Rothwell's paper. Mr. S. J. Rothwell presented an alternative method for channel flow measurement based on differential head loss. The summary does not mention accuracy data, cost, or installation time. Rothwell's paper was not included in the full proceedings volume published in November 1934. Hudson later told a colleague that the editorial committee decided the method was insufficiently validated for international dissemination. Samuel Rothwell returned to the Murray District in April 1934 and continued installing paired sluice gauges. By the end of 1934, he had 41 installations across 7 irrigation districts. In 1935, the New South Wales Department of Public Works issued a memorandum to all district engineers stating that paired sluice gauges were approved for billing verification in disputed cases. The memorandum did not replace Manning's equation as the primary method. It created a 2-tier system. Manning was used for billing. Paired gauges were used when farmers challenged the bill. This created a problem. Farmers now knew there was a more accurate method. Every time a paired gauge measurement came back lower than the Manning calculation, which it did in 73% of cases between 1935 and 1937, the farmer requested a billing adjustment. The Water Authority had to issue refunds. In 1936, the Murrumbidgee irrigation area issued 284 refunds, totaling £1,947. The refunds were calculated based on paired gauge measurements. The original bills had been calculated using Manning's equation. The financial impact was not sustainable. In March 1937, the New South Wales Department of Public Works commissioned a review of flow measurement policy. The review was conducted by a 3-person committee: Sir William Hudson, who had chaired the 1934 conference session, Donald Frame, who had verified Rothwell's first installation in 1932, and Dr. Herbert Noon, a hydraulics professor from Sydney University who had not been at the 1934 conference. The committee was asked to determine whether paired sluice gauges should replace Manning's equation as the standard billing method. The committee reviewed installation data from all 41 paired gauge sites. They reviewed accuracy comparisons. They reviewed cost data. They conducted independent current meter measurements at 6 sites and compared them to both Manning calculations and paired gauge readings. The current meter measurements took between 3 and 5 hours per site. The paired gauge readings took under 4 minutes. The current meter measurements agreed with the paired gauge readings to within 5% in 5 of the 6 cases. The Manning calculations were off by an average of 21%. The committee's report was submitted in September 1937. The report concluded that paired sluice gauges were more accurate than Manning calculations for billing purposes. The report recommended that Manning's equation continue to be used for system design and capacity planning, where absolute accuracy was less critical than relative consistency. For billing, where accuracy directly affected farm income, the report recommended adoption of the paired sluice gauge as the primary method. The report estimated the cost of installing paired gauges at all billing points in the New South Wales irrigation system at £4,780. The annual savings from eliminating disputed billing refunds was estimated at £2,100. Payback period, 2.3 years. In November 1937, the New South Wales Department of Public Works issued a directive that all irrigation billing after January 1, 1938, would be based on paired sluice gauge measurements. Manning's equation would remain in use for design purposes. The directive applied to all state-managed irrigation districts. Private irrigation companies were not required to comply, but were encouraged to adopt the method. Between 1938 and 1940, New South Wales installed 327 paired sluice gauge sets across its irrigation systems. The installations cost £4,890, slightly over the estimate. Billing disputes dropped by 81% in the first year. Farmer satisfaction surveys conducted in 1939 showed that 68% of respondents believed the new method was fairer than the previous system. In 1939, the Victorian State Rivers and Water Supply Commission sent an engineer named Colin Grant to inspect the New South Wales installations. Grant visited 9 sites, reviewed the installation procedure, and took independent measurements at 3 locations. He reported back that the method worked as described. Victoria began installing paired gauges in 1940. South Australia followed in 1941. Queensland installed its first set in 1943. Outside Australia, the method spread slowly. In 1940, the Indian Irrigation Research Institute in Punjab invited Rothwell to present his work. Rothwell traveled to Lahore in March 1940 and spent 3 weeks training engineers on installation and reading procedures. The institute installed 12 paired gauge sets in the Sutlej Valley Canal system. The results were published in the institute's annual report in 1941. The report noted that the method was effective in channels with stable beds but required frequent releveling in channels with high sediment load, confirming the concern raised by Dr. Caulfield in 1934. 1946, after the war, the Food and Agriculture Organization of the United Nations held a conference in Washington, D.C., on global irrigation efficiency. Samuel Rothwell was not invited. His method was, an engineer from the New South Wales department, whose name was Alan Crawford, presented a paper on differential energy measurement using paired sluice gauges. The paper included 12 years of operational data from Australia and 4 years of data from India. The accuracy data was consistent across all installations. The method was more accurate than Manning calculations. The cost was lower than current meter surveys. The time required was a fraction of either alternative. The FAO conference proceedings, published in 1947, included Crawford's paper in full. The proceedings were distributed to member nations and translated into French and Spanish. By 1950, irrigation authorities in Egypt, Iraq, Cyprus, and southern Rhodesia had adopted paired sluice gauge measurement for billing purposes. By 1960, the method was standard in 14 countries across 4 continents. The differential energy method was never patented. Rothwell never attempted to commercialize it. In 1952, an irrigation equipment manufacturer in Sydney approached Rothwell and asked if he would license the design. Rothwell said no. The manufacturer asked why. Rothwell said that his father had been overbilled for water he never received and lost the ability to contest it because no one believed the farmer's measurement over the engineer's calculation. He said he designed the method so that farmers and engineers would measure the same thing and get the same answer. He said charging money for that would miss the point. The paired sluice gauge is still in use today. The modern version is called a differential pressure flow meter. Instead of brass staff gauges read by eye, it uses pressure transducers connected to digital data loggers. The principle is identical. Measure the head loss between 2 points. Calculate flow from the energy difference. The modern devices cost between $800 and $1,200 depending on data logging features. They are used in irrigation districts, municipal water systems, and industrial process control. The underlying equation is still the Darcy-Weisbach equation that Rothwell used in 1932. The innovation was not new math. It was applying old math to the thing that could actually be measured accurately in the field. Samuel Rothwell continued working for the New South Wales Department of Public Works until his retirement in 1958. He was promoted to senior engineer in 1945 and to chief irrigation engineer in 1951. He published 17 papers on irrigation measurement and channel design between 1934 and 1957. None of them received the attention that his 1934 conference presentation did, but none of them were laughed at either. He died in 1966 at the age of 73. His obituary in the Sydney Morning Herald was 4 sentences long. It mentioned his career with the Department of Public Works and his contributions to irrigation engineering. It did not mention the 1934 conference. It did not mention that he had been laughed at for being right. The original paired sluice gauge from the Barraquin Irrigation District installation in 1932 is in the collection of the Powerhouse Museum in Sydney. It is in storage, not on display. The brass rod is still marked in 16th-inch increments. The cast iron base still has the expansion bolts attached. It weighs 11 pounds. It is the thing that proved you could measure water more accurately by ignoring everything the experts thought mattered and measuring the one thing they thought did not. If you have worked with irrigation systems, or if you know someone who was billed for water they did not receive, or if you farm anywhere that water is measured before it reaches your field, leave a comment. Tell us where you are farming and whether you have seen a flow measurement system that looks like 2 staffs mounted 100 feet apart. And if you want to see more stories about the people who were told they were wrong and turned out to be right, subscribe. We are documenting the ideas that were rejected before they were adopted. Let us know where you are watching from.